Welcome to the Explainer. Today, we're cracking open an essential toolkit for anyone who works with data, SQL. We're going to look at the powerful commands that let us connect, summarize, and manage information with some serious speed and precision.
Okay, think about it. How does that even work? Well, it's not magic, it's just really smart logic. The secret is having the right SQL tools to combine all those different bits of data, zoom out to see the big picture trends, and manage it all in a structured, super reliable way. And today, that's exactly what we're going to get our hands on.
So here's how we're going to break it down. First, we'll see how to bring scattered data together using joins. Then, we'll learn how to actually make sense of it all with aggregation. After that, we'll go behind the scenes to look at the foundational objects and rules that keep a database humming, master some key commands, and then finally, we'll zoom out to see how SQL fits into the bigger database universe. First up is probably the most fundamental job in any database, linking related information that's stored in different places. This is where we get to unleash the power of joins. You can really think of joins as the super glue of your database. I mean, you've got a table of customers over here and a table of their orders over there. How do you connect them? Well, a join lets you link them using a piece of info they both share, like a customer ID, so you can ask questions across both datasets at the same time.
Now, what's so cool here is that you have a whole set of tools for different situations. An inner join, for example, is perfect when you only want the clean intersection, like show me only the customers who have actually placed an order. But what if you need to see all your customers, even the ones who haven't bought anything yet? Well, that's a job for a left join. And trust me, knowing which join to use is absolutely critical. Otherwise, you can get some really weird or just plain wrong results.
All right, let's move on to the next tool in our kit. So you've joined your data, but now you're staring at this massive wall of information, maybe thousands or even millions of rows. The next step isn't just to see the data, it's to understand it. And that's where aggregation comes into play. The group by clause is your secret weapon for turning that chaos of individual records into clean, summarized categories. So instead of looking at every single sale one by one, you can use group by to organize them into neat piles, by product, by region, or by customer. It really sets the stage for some much deeper analysis. And these functions, they're the partners in crime for group by. Together, they answer the most important business questions you can think of. You know, how many orders did each customer place? That's count. What was the total revenue per region? That's sum. What's our average sale price? You use AVG for that. This is literally how you turn raw data into real intelligence. Okay, now let's pull back the curtain a little and look at the architecture that makes all this possible. These are the behind-the-scenes objects and rules that make sure our data isn't just sitting there, but that it's also fast, reliable, and, intelligent. So here's the crucial takeaway. If your query is running slow, the very first thing you should think about is an index. It's just like the index in the back of a book. It stops the database from having to read every single page to find what it's looking for. It just jumps straight there. Seriously, understanding indexes is the key to making a slow database dramatically faster. Constraints are pretty much the unsung heroes of data quality. Think of them as the strict rules you set up for your tables to stop mistakes before they even happen. They're like a bouncer for your data, making sure only the good stuff gets in and everything stays consistent and reliable. And each one of these has a really important job. A primary key that gives every single row its own unique ID. A foreign key builds that critical link between tables that, by the way, makes our joins possible in the first place. And a check constraint can stop someone from, say, entering a negative number into a price column. Together, they create this rock-solid structure for your whole database. Triggers are basically your database's automation engine. Let's say you need to create an audit log every single time a salary is updated. A trigger can do that for you, automatically. Need to enforce a really complex business rule that a simple constraint can't handle? A trigger is the perfect tool for that job. So we've got the foundation, we've got the rules of the game. Now let's look at some of the power moves, the commands that give you precise hands-on control over your data. And this one is a classic. It all comes down to a simple trade-off, precision versus speed. Think of delete as a scalpel. It removes rows one by one, logs everything so you can actually undo it if you mess up. You'd use it to carefully remove one specific user. Truncate, on the other hand, is a sledgehammer. It wipes an entire table in one go. No logging, no questions asked. It's way faster, but there is no turning back. It's perfect for when you need to just nuke a temporary table and start fresh. Now here's something you have to remember. SQL is designed to work with entire sets of data all at once. But sometimes Every once in a while, you absolutely have to process things one row at a time. For those special cases, you have the cursor. It lets you loop through your results one by one to do some kind of complex, row-specific task. It's a specialist tool for a very specialist job.
And we can't forget the star of the show. I mean, nearly every single tool we've talked about, joins, aggregations, indexes, they all exist to support the ultimate goal of the select statement, getting exactly the right data in exactly the right format at precisely the right time. It is the reason everything else is there.
All right, for our last section, let's zoom all the way out. We've been deep in the world of SQL. But how does it stack up against its modern, non-relational cousin? Let's take a look at SQL versus NoSQL.
The most crucial point here is that it's not about which one is better. It's about using the right tool for the job. SQL databases give you rock-solid structure and reliability, which is perfect for things like financial transactions. NoSQL databases, on the other hand, offer incredible flexibility and scale. That makes them ideal for handling massive amounts of unstructured data, like, say, all the posts from a social media feed. And that really is the fundamental question that developers and data architects are wrestling with every single day. As data just keeps exploding in volume and variety, that choice between strict integrity and massive flexibility, it's only going to become more critical.
Thanks for joining this explainer.